When light hits an object, it is reflected back into space and forms a line, which I will call line L. E is a point on line L. A, B, C, and D are points on the object. From point E, it is possible to see that point A is to the left of point B and above point C, which is to the left of point D. On point E is the information of the relative position of those 4 points on the object. From point E and from each point on line L, it is possible to see the relative position of infinite points on the object. On each point on line L is the information of the relative position of infinite points on the object. The influence of infinite points on the object moves along line L. Anyone that stands on line L will be affected by infinite points from the object that converge at that point. For every point on one of the object's dimensions, there are an infinite number of points on the other dimensions. In the same way, for every point on one of the object's dimensions, there are an infinite number of points on the line L. For every point on line L, there are an infinite number of points on each of the object's dimensions. Line L is the 5th dimension of that object. A two-dimensional being who lives in a two-dimensional world is able to move freely in its world, but it cannot turn so that its right side becomes its left side. In order to do that, it must use a higher dimension than the two it is in. If it could leave its two-dimensional world, it could use the 3rd dimension to turn, and then return to its two-dimensional world. Its internal organs would change their relative position. Its heart, for example, which was on the left side of its body, would now be on the right side of its body. A two-dimensional being can't turn like that in a two-dimensional world. This is also true for three-dimensional objects in our world. A three-dimensional object can move and turn, but the relative position of each part within it stays the same. It cannot turn so that its right side becomes its left, and vice versa. To do so, it must use a higher dimension than its 3. The light that is reflected from the object allows us to know the relative position of infinite points that are found on the object. Therefore, the three-dimensional object can be divided into a number of parts. Since we know the relative position of each part, we are able to move each part to a new position and to exchange between the object's right side and its left side. The three-dimensional object can be divided into more parts, and we can change the relative position of each part within the object. Notice that the right side of the object becomes its left and vice versa. By knowing the relative position of every particle within the object, it is theoretically possible to exchange between the object's left and right sides even on the atomic or subatomic scale. If moving atoms seems impossible to you, read in the attached link about how in as early as 1989 IBM scientists moved 35 xenon atoms to form the letters IBM. Theoretically, it is possible to turn any three-dimensional object in this way, even a human being. All of his internal organs would change sides. His heart, for example, would be on the right side of his body. It is possible to turn a three-dimensional object in this way only by using a higher dimension than its own 3. Each object that you see has a 5th dimension that enables us to see and change its position. Take this speaker, for example. Let's mark a point on it and call it point A. In point A, the speaker has an infinite number of points on its 1st dimension length, an infinite number of points on its 2nd dimension width, and an infinite number of points on its 3rd dimension depth. Let's draw a line from point A to the wall and call it line L. There are an infinite number of points on line L. On each of those points is information of the relative position of point A. Line L can be in any direction. In each direction it will have a different length that can be measured by using a measuring tape. Line L is the fifth dimension of that speaker in point A. Since the information of the relative position is found as a volume and not just in a line, there are three information dimensions which are perpendicular to each other. These are the fifth, sixth, and seventh dimensions of that speaker in point A. Every object that you see has three spatial dimensions and three information dimensions. That is why 6 numbers are needed to describe the position of each point on an object. One number for each dimension. Take, for example, point A on the speaker. There are an infinite number of points on the first dimension of the object. The first number out of the 6 numbers indicates the position of one point, point A, out of the infinite number of points on the first dimension. The second and the third numbers indicate the position of point A on the second and third dimensions of the object. There are an infinite number of points on line L. The fourth number out of the 6 indicates one point on line L, which we will call point E. The fifth and the sixth numbers indicate the position of point E on the sixth and seventh dimensions. Point A's physical location does not change, so its location on the first 3 dimensions will not change. For every point A, there will be only one value for its first, second, and third dimensions. Point E, however, which is on point A's informational dimensions, has an infinite number of values. Therefore, for every point A, there will be an infinite amount of points E. Each point E will have a different set of 3 numbers describing its position on the 5th, 6th, and 7th dimensions of point A. The 3 information dimensions are alongside the 3 spatial dimensions and enable us to know and to change the structure, size, and the relative position of objects. The 3 information dimensions are the 5th, 6th, and 7th dimensions of an object.